A binary search tree, or BST, is a binary tree where all nodes in the left subtree of the node are smaller than the node itself, and all nodes in the right subtree are greater. This property has to hold true for every node in the tree. To determine if a binary tree is a valid BST, we can use a recursive approach that checks each node and its subtrees to make sure this rule is followed. For the solution, we will walk through. So the recursive function works by checking each node with a valid range of values. We pass a minimum and maximum boundary as we traverse the tree. Initially, these boundaries are set as unbounded for the root node. As we move to the left subtree, the current node's value should be less than its parent. So we adjust the maximum boundary when moving to the right subtree. The value should be greater. So we adjust the minimum boundary. At each node, we check if it satisfies the constraints and recursively apply the logic for all nodes. If any node breaks the rule, we return false, indicating the tree is not valid BST. So here also, I would like to give a C# code sample. For example, public class tree node in bracket public int value, public tree node left, public tree node right, public tree node in parentheses int value. Then open another bracket, value equal value, left equal null, right equal null also. Then public class binary tree, open bracket, public bool is BST, the tree node root. Return is BST helper, root int minimum value and int maximum value. So as explanation of this code, the tree nodes class, this represents each node at the binary tree. It has a value, a left child, and a right child. Is BST method, this is public method that checks if the tree is valid BST. It calls the helper function is BST helper with initial bound set to the smallest int minimum value and largest int max value, possible values. Is BST helper method. In the base case, if the node is null, then return true. Check the current node. If the node value is not within the range, minimum value, comma, maximum value, then return false. Recursive code. The left child's value should be less than the current node value. So we update the maximum bound to the current node's value. The right child value should be greater than the current node's value. So we update the minimum bound to the current value. In conclusion, this recursive function efficiently checks whether a binary tree is a binary search tree by validating that each node adheres to the BST property. So each node is checked in constant time, and the function curses over the entire tree, making the time complexity, which is O in parentheses n, where n is the number of nodes in the tree.